Got my little starting thing, but there it is. Alright, so what I'm doing right now is I'm writing a piece of documentation for new programmers on punt-engine. Punt-engine is my, or R is a better pronoun. If that's even what a pronoun is, I couldn't tell you. It's this trading on FPGAs thing. And today we're documenting how can someone that doesn't know anything about hardware that's like a first year CS major understand everything in this, and this. So that's what we're doing today. That is what we're doing today. And I'm not even on the right screen. Pick this up. Let's get into it. You know what I mean? So, even I can't remember everything that's in this. So you probably need CMake too, yeah? Maybe it's styled like that. So in this one, I really want to be in cores moving average here. Maybe in V split this with the moving. For some reason my escape key is slow. It's kind of annoying, bro. Slick annoying, bro. Oops, so we're gonna need a... I also just switched to using Tmux. So give me a minute. Also, is my camera in the best spot? I feel like the best spot might be bottom right. Is that where it is? No, it's in bottom left. So I think I'm gonna move this thing. Right. Should probably go ahead and do this and this. And we'll group, you know what I mean? Group these things, slap them over here. Satisfied with that. Let's do the same with these. Group this and this. This. Okay, group this. Oh my god. Group this. Sure, group two. Put this and this in there. FreeBSD on top. Just throw this guy over here. Sure. Taking a break. That's fine. That's fine. IP, that's fine. Alright. So you're gonna need a make file, you're gonna need this to be the last one. sbench.c++. You compare the output of a software test bench to that of our accumulator core to ensure. Why did it just duplicate that? Huh? Dude, my escape key. Nah, my escape key's glitched, bro. Because yeah, when I use my bind, that just binds to escape, so it's definitely on the OS side, whatever my escape key is doing. You might need GTK wave. Pair setup, let's begin. Intuition. So, consider the interface to an accumulator simplest interface to an accumulator circuit. Could be two. So like what even is our interface here? So we have a did it have like autofill when I did that? Oh, it just happened to be the same. So I mean here's what that looks like. It's gonna be this. Yeah, I didn't want that. I wanted that was the worst way to write that, but So we take in a stream of prices. That's the foundation, but what is the ROI for the circuit? We take in a stream of prices. I'm going to clarify at the top as to what exactly we're voting. What are the last n samples? Will parameterize. Again, did I use that too much? Parameterize. So I'll switch this to control here. We'll parameterize the bit width of the price, namely n, and the sample length, or in the we'll parameterize k, and bit width price, namely n, using the SystemVerilog parameter. Let's begin. So let's just quickly check what we're looking at here. Looks solid. Consider the simplest interface to an accumulator circuit. Like any clock circuit, will have an input wire clock. I'm thinking if I need to explain what clock and reset is. Do you know what clock and reset is? Honestly, I don't think I knew what that was. Sure. So, dude, I feel like there's so many ways to look that up though, so I'm gonna skip that one. That's the foundation. I never really checked the stream either. It's fine. Right, and wires. these wires together by the representation of 2 to the n minus 1 values. In our case, these values are prices. So the valid inputs, so we'll have an input wire unsigned en, which holds the price that we are to sample on the next rising clock edge. We don't want to lock users of this circuit to only a certain n value. The core should be agnostic to the asset the bit depth of the price that it is accumulating. The bit depth of the price of the asset that is accumulating. So we'll abstract away this and using what is it? A parameter called data width. All right, so just go in here, paste that. And it's going to complain about this, so we can just rename this to moving average accumulator of average ag. So n, I kind of overloaded n in this comment, so let's probably remove that. Alright, so let's verify that looks good here. Break down the syntax a bit. The first, so module move average ag. So what exactly, so even I could use some help on this. What exactly is a module in SystemVerilog? Finds a reusable hardware component called move average. Other modules can embed this module, linking their wires to the so what do you call like these things? You have the module, you have the IO, the parameters. Next is a list bound by This is a parameter list. This is the parameter list. Here go magic numbers. Here go constants like exponent, which we said was k. It's actually log base 2 of k. And data width. And that's log base 2 of n. Or that is n, because you said. When constructing, sorry, when synthesizing our ACC core, we can pass these parameters in without having to go in and change the internal RTL. Finally is this list bound by oh my gosh. Is it just called the IO list? It's like this. What do you call that thing? SystemVerilog, like a file broken down. Oh my god. IO list, is that what it's called? IO list? Within this list are all IO. In our case, we have 3 input wires as described above. We have the 3 inputs and 1 output described above. And then so with these inputs, we perform some logic, produce an output. This output is going to be a price. So it will be the same type as the VN. Okay. This isn't like the best writing. Like if I was writing something on my own side, it'd be better than this. But I don't really care. You know what I mean? So we have that. The algorithm. We can call it data structures and algorithms. Or perhaps we'll go into circular buffers. So let's ignore the interface described above and generalize the moving average problem a bit. We have a stream of prices over time and want to maintain the average over the last k of it. Naively, computing an average involves summing up all samples in a set, dividing that sum with a set. You can imagine a naive implementation of the circuit that has an array size k. Consider an implementation of the circuit that maintains an array of size k. On each clock edge, let's first start with an array of infinite size. On each clock edge, push the current price value dn on top of this stack. Then we sum up the top k elements on the stack. Divide that sum by k. And put that result into the register dout. Problem with this is that we don't have infinite memory. So instead of an infinite large stack, we'll maintain an array of size k and a pointer so the pointer is implemented as our oldest index. The oldest index in K. Since we're only concerned with the K most recent samples on a given clock edge, the value pointed at or the price at the arrays price in the array at index, a pointer to the oldest index in K, called oldest index. The price in the array at oldest index is K plus 1 prices ago. It's K plus 1 samples ago. Hence should and hence does not impact the value push to D. So on this new edge, we can just overwrite array index dn fixing the infinite memory problem. So now we have an array in our circuit K most recent samples. On each cycle, we could sum up the array in O of K time and divide by K and be done. It's a bit naive though. We can sum the array in O of 1 time by realizing that on a given edge, that on a given cycle, we increase the sum by the n and decrease it by array index. AKA the AKA the price K one samples we got. Or it's like K samples we got. It's not really K plus one. Yeah, it's not really K plus one. Summing up. Just subtract. Just sample. And add. Yeah. When we divide by. There's one last optimization. There's one last optimization. Imagine that in the circuit above, K is N. We're calculating the average over the last 10 seconds. Dividing by 10 on computers is slow and difficult. Use a floating point unit and deal with fractions of price. Or use floor division. How does floor division work? In hardware. Talking about in freaking hardware, dude. Even then, there's a faster way. in less than 1 second. So, what are the things to note? Like, not move window. Oh my god, stop, 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 stop. So, the things to note is that the bit width of some bit width of some array is not equal to n. Sum of we call that the array consists of k elements of size data width from 1 down to 0. We cannot store this sum in the calculation of d out. We can't simply store this sum in a wire size n in an n-bit wire because we will have overflow. We cover the case to prevent overflow. Our temporary sum wire must be of size kn. Is it k plus n? Wait, am I cooked? It's k plus n. Yeah, it's k plus n. I'm cooked. Right? K plus n. 1 ago, 2 ago. Why'd I get on the test bench? Yucky. Here's my escape key again. So the sum is of act width, and act width is data plus exponent. So I've kind of made n a bit ambiguous. Overloaded and hence ambiguous. So far, I've used n to denote. So it's really only k that's ambiguous. I've used n to denote the. What was I using n to denote? Because it's you kind of have to log to it, whether you consider the total size of the type, if you want to call it that, or if you're actually talking about just the bit width, which I'm talking about the bit width as somebody writing the Verilog, but somebody that's just reading this, like before knowing that, would probably just say what? Because what did I say this? Okay, I gotta turn this off. Okay, so. Okay. So k was the bit width. Back and forth a bit between n and k. As yeah, that's just kind of annoying. So so in the circuit we have this. Note that this is not a drag in the circuit's list. And it's a local / intermediate. Local point. Convenience. Have these. They define n the aforementioned n, but uppercase would match formatting standards. So and defines different n, but it's not from width is the length of the bit depth of the reg, which is the numerator in the average calculation, aka the sum of the elements of the array. Okay. So the local param keyword is a bit like C's define. Set up these aliases to avoid pasting. Spawn value. That's not the best way to say our values, but I just think it's kind of funny. So is there anything else I should say before just pasting this? For loops. Description. In the code below, you'll see a loop that instantiates elements of the array sample history, here named sample buffer. Be this. Software programs, apps. So remember that we are describing software. For here is not the imperative that it is software. It is here. It essentially is a compile time that expands into an assignment element sample buffer 0 copy paste assignment for each hard coded I up to n. This loop does not on some type iterative operation. And I'll probably need one on how to do like now, that's fine. It's fine. This is actually really easy. Okay. So this is doing like sign extension. Let's go into SB. I'm sure maybe that's what it's. Okay, so I accidentally used K too much. Ah, frick. So N is K. I kind of mix it up. K is equal to 2 to the log base 2 of K. No, K is equal to the log base 2 of K. So we're not going to call this N. We're going to call this K. So where we say N, let's say K. SV is not a thing. I think it's just V. What was that? Okay, I gotta go to the bathroom. I guess that's okay. Yeah, I guess I don't know what V is. Isn't V a pro? I think V is actually a programming language. Okay. All right, I'm going to the banyo. Alright, I got a lot to do. I just really want to finish this. Already been working on it for an hour. Let's just finish this. So we do need to describe the sign extension. Okay, I might ask Jippity just to do that. Just save me like 10 minutes. Chat.com. Давайте еще на... I want to listen to Pinata. Yeah. Ладно, вообще. Yeah, so this is the only thing we don't understand yet. Yeah, so what did I want to do? The whole point of me doing that in the first place. So you go here, go to chat. Alright, stop just screaming into the mic, my bad. I've also, I don't know if you noticed, but I've been doing this high contrast, low saturation, varies value, hue indifferent as a result of saturation setup. It's quite nice. Just what, like, I don't know. After, well, I mean, I've been praying, what is it, 2025? March 2025 will be 5 years of prayer. Whoa, that's crazy, dude. To be fair, I was trash for like 4 of those, but wow. That's crazy. I didn't even realize that. That's really insane. But yeah, after like 5 years, I think you get tired of the, oh, my editor, operating system, window manager, browser, everything looks like a freaking clown shop. Freaking candy shop. Clown. Convention. Rainbow. It is kind of relieving just to, not relieving in that it's something that I came back to, but relieving in that it's just nice and pleasant to have something that's just grayscale and thing. But yeah, let's finish this up. Stop it, yeah. So here's what we're just pasting in the Jippity. Not pasting, interpolating. So sign extension. Okay, I'm just copying this. I'm not copying. Sign extension. We call the operation where we subtract out the oldest sample and add in the newest. Here's the code for that. Oops. 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 Oh my gosh. Oh my gosh. I hate the orange. I don't know how to get rid of the orange. Okay, so my automatic detector of whatever is not working. So if we just go here, here's DT, that's not gonna work. Here, it's like here. Is it just one? Dude, oh, this is so AIDS. I think it's two. One, two, three, four, five. That's six. So we're subtracting out. Oh. I gets. Okay, I don't even remember what this is. How does this junk work? Oh, we still gotta do the test bench and the make file. I'm shooting myself. Low key, I don't even get it anymore. It's probably been. When was that edited? Last. Oh no. That's embarrassing. Okay, it was moved. Okay, it was like November. I think I get a break there. Yeah, I don't remember what that syntax is. I gotta mute this just to understand this. I remember now. The replication operator to copy the most significant bits. Bit. Okay, so we're. What's the comma after? What's the comma?
Back with sample buffer, and then you comma the sample buffer. Concatenated. Oldest index. So it's the oldest index. Concatenated. Concatenates. Okay, so yeah. That first one takes. Okay, I feel like the branching is a bit complicated. The formatting makes it seem, yeah. So this replicates forms a signed extension. It replicates most significant bit of oldest sample. Why do we even need this in unsigned? Yeah, all of this is unsigned, right? Wait, so is it actually adding the one there? Because the one shouldn't be interpreted like that.
Yeah, keep accidentally doing this. Feed to here. So let's explain it in comments. You need to include don't know if make is valid or not. Node modules format make valid. How do you run this wiki? Should be in the README. It's not. Should be in the CI workflow. So I don't think it comes with a make, but I can figure that out. So okay, we're just gonna submit this git add -a. Oof. Oh my god. Wait, why is it not getting ignoring node modules? Why is it not getting ignoring node modules? We've had this in here for such a long time. It's perplexing. Docs support cache, corrected. That's pretty annoying. Docs. Ignore such quartz. Study detail. So what did I? Wait, how do you go back up through the freaking history, dude? So we added docs, content, flag, everything in public. I guess docs wasn't there before. Push. Gosh. Can I just dash F it? Everything needs to be on a pull request. So I think this is gonna break Wiki. It's freaking annoying. So it is a cloud.
Hey, all the tests passed. Yeah.
All right, so that's that. And that's that. I'm done. That was pretty free. On to the next. I gotta cook and read, do some other stuff, and get to bed at a decent time. It's already 8:17. Yep. See ya.